Okay, now I know. Hello everyone. In this video, I'm going to walk through my solution for question number 1 of problem set 5. The problem asks us to open stores along a street to maximize total revenue with the condition that two open stores must be separated by at least 3 blocks. And I will explain my approach, walk through the code, and then show the results on 5 different test arrays. So the problem as the input is an array where each element represents the expected revenue of an opening store at that block. The constraint is that if I open a store at block X and the other store at Y, then Y minus X has to be at least 4. Now, the first thing I notice is that a greeding approach does not work here. If I just grab the available block every time, I might end up opening a low revenue store early and completely missing a much higher revenue store just a few blocks away. So I use dynamic programming instead because it guarantees the optimal solution. So the core, I will just show my answer. Maybe that will help. Okay, so the core idea is to define a subproblem. I define max profit I as of the maximum revenue I can earn from block 1 through I. At every block, I have exactly two choices. Either I skip the block, in which case the best revenue I can get is whatever I have already achieved up to the previous block, or I open a store at block in which case I earn the revenue at block I and add it to the best result from 4 blocks earlier, because the spacing constraint means the previous store had to be at least 4 positions back. So I take maximum of these two options at every single block. This build up the answer from left to right, and because I'm reusing value I already computed, the whole thing runs in O of n time, which is good. Let me just walk you through the actual code. The function is called max revenue dp and it takes the revenue array as an input. I start by getting the number of blocks and setting up two arrays. The first one is called max profit and it stores the best revenue available up to each block. The second is called store open and it is a boolean array that tracks whether I decided to open a store at each block. I needed that second array to trace back the solution at the end. Then I just loop through each block from 1 to n. For each block, I calculate two things. Revenue, if skip, is just the maximum profit from the previous block, meaning I do nothing at this blocks. Revenue, if open, it means it's the revenue at the current block plus the maximum profit from 4 positions back, which automatically satisfy the spacing constraint. I also check that the current index is at least 4 before looking back, otherwise I just use 0. After the loop, I do the trace back to find which blocks to actually open. I start from last block to and work backwards. If store is opened is true at the current position, I record that block and jump back by 4. And if it's not, then I just move one step back. This gives me the exact list of open and I return it sorted along with the maximum profit. Now these are my test results on 5 arrays. So test 1 uses the binary array from part A of the problem. The algorithm correctly selects 2, 6, 10 and 14 with a maximum revenue of 4. And now test 2 is from part B. The algorithm selects block 3, 7, 11, 16, which matches the manual traces I did in the problem set. Now test 3 is the counter example I used in part C to show that greedy fails here. The algorithm would have opened a store at 2 because it starts from 2 for a revenue just 1, but the dynamic programming solution correctly identified that block 5, 10, and 14 for a total revenue of 170, like 100, 50, and 20. Now, test 4 has 21 elements with mixed revenue values. The algorithm selects stores at 3, 7, 11, 15, and 19 for a total revenue of 42. And lastly, test 5 has 25 elements where every fourth block has an increasing revenue value. The algorithm picks all 7 profitable blocks for a maximum revenue, and it comes across as 280. So, to summarize, the dynamic programming approaches solves this problem in just big O of n time by building up the optimal solution one block at a time and then tracing back to find exactly which stores to open. And that was it. Thank you so much for watching this video. Have a great day.